is I had this picture. This one had 5 beautiful girls, no? Like this, all are beautiful. All are beautiful here. Girls and these are they are ugly here. I'm talking in Sinhala, anyway, so this girl is not beautiful. These four are beautiful, and the last one is they are not beautiful. So I guess I have labeled them as A, B, C. So here there are 5 beautiful girls. Here there are 4 beautiful girls, 4 beauties, and one who is not that beautiful here. Let's say you. They are not beautiful. So, as far, let me read what I have written. There are 5 very beautiful girls in class A. In class B, there are 5 girls. 1 girl is not that beautiful, and the other 4 girls are very beautiful. Class C has 5 girls as well. Unfortunately, girls in this class are not beautiful. Right? The situation is there. Consider the following statements about the girls in classes A, B, and C. Determine whether each statement is true or false. I say the first one is every girl in class A is very beautiful. Is that true or false? True. That is true. Every girl in class B is not very beautiful.
False.
Every girl in class B is not very beautiful. Buddha, what do you say?
False.
False. And third one, every girl in class C is not very beautiful.
True.
True. Very good, very good. Because it is very easy to see that 1 is correct, 2 is false, and 3 is correct. Negating a universal statement. Now, universal statements are statements with for all, for every, with these quantifiers, no? For all, for every, etc. I have given 3 for each. Negating a universal statement produces an existential statement. This is very important to understand, to do analysis. When you are doing group theory, ring theory, number theory, actually you don't have to know that much logic. Of course you have to be logical in order to prove theorems, but not up to the level of analysis. In order to do analysis, it is very important. Because I have seen some notes of some lecturers, algebra lecturers in Sri Lanka. I mean, it is like arithmetic. They have written the way. We cannot afford to do it. Now, here there is a statement, all swans are white. Negation of all swans are white is not all swans are not white. We are tempted to say so, no? The statement is all swans are white. I want the negation of it. Somebody may say all swans are not white. But rather, there is some swan which is not white. No, that's the negation. Here, every girl is beautiful. Negation of this one is, there is at least one girl who is not beautiful. Very important. Every girl is beautiful. Negation is, every girl is not beautiful. That's wrong. Here, every girl is beautiful. We cannot say here every girl is beautiful, or we cannot say here every girl is not that beautiful. Either one is false. So, when you negate an universal statement, you end up with an existential statement. Here, now the negation of for every x, for every 0 less than x less than 5 by 2, cos x greater than or equal to 0. Because the graph of cos 0 is 1 like this, no? Here is 1, this is 5 by 2, this is cos x. Graph of cos x. So for every x between 0 and 5 by 2, cos x greater than or equal to 0. That is a true statement. And if you negate this thing negate this one, you get for some negation of this one, for some 0 less than x less than 5 by 2, cos x less than 0. This one is a true statement, this one is false actually in this case. There is no x between 0 and 5 by 2 such that cos x less than 0. This is false, but what I did was here, we wrote the negation of this one. Negation of this universal statement became this existential statement. What we do is, actually for every goes to for some, and this one, say this one is px, here you have to write not px. For every x, say for every x.
Good morning, sir.
Good morning, good morning. For every x px, negation of this one is there exists x, not px. However, we should not practice without thinking, because it is dangerous. When you are doing analysis, you get for every x there is a y, for every x it goes. So you have to have the idea. At the very beginning, it is okay to write like this, but on the contrary, always very important to have the idea, because you cannot practice patterns to understand logic. Negating an existential statement produces a universal statement. When you negate a universal statement, you get an existential statement. When you negate an existential statement, you get a universal statement. The negation of there exists a black swan here. There exists a black swan. Negation of this one is, somebody who does not know logic may say there exists a swan which is not black. That's not true. There exists a black swan. Negation will be there exists here in the note saying it's not there exists a swan which is not non-black, but rather all swans are. Negation of this one is all swans are non-black. There exists a black swan. Negation is, those who don't know logic, they say there exists a non-black swan, but the real correct one is all swans are non-black. For instance, here if you have, how do you draw a swan? Like this? Something like this, okay. Let me draw, this is good enough. There exists a black swan. Suppose there is one black swan here, at least one, then you can say there exists a black swan. However, if usually swans are white, no? Then if all of them are white, you cannot say this one. Then you have to say all swans are non-black. You have to get that feeling, because you are talking calculus, derivatives, then integral, continuous functions, continuity, differentiability, integral, series, convergent series, divergent series, convergent sequences, divergent sequences. All of them are about universal and existential statements. We say there is nothing called derivative in this world. No, I mean, really there is nothing. So this is in mathematicians' brains. Derivative has a definition. It says we will come to that later, I guess. For each epsilon greater than 0, there exists a delta greater than 0, such that, again, for each x belongs to something. It is like that. All are for this universal quantifier and existential quantifier. They appear many times in the same statement. Those who don't know that it is a logical concept, that's why they have different arguments. Many people don't know. Many, actually. Once in a way you run into a person who knows the derivative or integral. Actually, in A level we don't study integration. That also many people don't know. Even teachers don't know. Sometimes I went to Maharagama, NIE to training teachers. Now they don't invite me because when I go there, because according to what I say, others are wrong. So I'm not invited anymore. So it is a dangerous thing in this country. However, when I say you don't do integration in A level, at least then you have to know the meaning of integration. It is not done in A level. This integration symbol, this one is used, no? Kokama, singular people, something. Those who don't study mathematics, when they say this thing, they say Kokama, no? So, derivative has a meaning. Derivative has a meaning. So, we just cannot say it, because sometimes what happens is, people cram derivative of sin x is cos x is negative sin x, and etc. No, they are statements with universal and existential quantifiers. I mean, it's a result of that. All suns are ananda. Similarly, the negation of the statement, there exists a real number x. Let me write in English, there exists a real number x. Real number x such that x square plus x plus 1 is equal to 0. Somebody says this thing, x square, there is a real number x such that. So the negation of this one is, I mean, is this true? Maybe not, no? This is not true, no? This is not true. Anyway, so the negation of this one is for every real number x. For every real number x. For every real number x. Then you have to put a comma. There must be a comma for every real number x. Can you see here, there exists a real number x, you don't put a comma. You don't put a comma. Here say there is a real number x, what kind of x? Such that, this thing, for every real number x, x squared plus x plus 1 is not equal to 0. So here is existential statement, here is the universal statement. I mean, it is dust. This one, new one.
The close enough.
This one is good.
Yeah.
It is good. So x square, actually this, we can prove this thing very easily. We don't have to do it, I mean just for doing it. This is like x plus 1/2 whole thing square plus 3/4. This is greater than or equal to 3/4 always. So it cannot be equal to 0. No? X squared plus x plus 1 is x plus 1/2 whole thing square plus 3/4. So it is all, this is a non-negative number, plus 3/4 has to be greater than or equal to 3/4. We are not doing math, for the time being, we are just doing logic, try to understand. So very important, negation of a universal statement is an existential statement, because sometimes most of the people, negation of for every x px, they read for every x not px. You have to be very careful. This is wrong. It is there exists x, not px. Similarly, there exists x, qx. Negation is for every x, not qx. You need to learn this thing by heart, not by memorizing. You need to get like this sort of pictures. So I will give you a tutorial, next day, I don't know whether I will give on Friday. Certainly, next week I will give, if I am happy with our work, I will give it this week, Friday, who knows. If you know a statement Px is true for all x, then you can set x to be anything you want. If Px, here in this case, for every x Px, you can take any x, Px is true for that value of x. That is what for all means. That's what I just wrote these symbols because just to say that we can use symbols, but we don't practice using symbols. It's not a good thing. Thus, for instance, if you know that x, I have written here x minus 1 cube is x cube minus 3x squared plus 3x minus 1 for all real numbers x, then you can conclude, for instance, that e minus 1 cube, I have written e minus 1 squared in the notes, make it e minus 1 cube is a mistake. E cube minus 3 squared plus 3 e minus 1. I also know that. I might prove it. However, if you know that x squared plus x cube plus 3x minus 5 equals 0 for some real number x, then you cannot simply substitute in any real number you wish. If you know that, this is very important. Suppose you know that x cube plus 3x minus 5 is equal to 0 for some real number x. Suppose this is true for some real number x, I can see that it is true. It is a true statement. Maybe you cannot prove it. Don't worry about the proof right now because you don't know what analysis now. Just because this is true, you cannot substitute any real number here. You cannot. Because all we know is there is. It is like, say, suppose we go to a place, say your parents meeting, for instance, so many parents are there in the hall. Say if you ask, what is your school? I have been to Ananda Zoo many times those days. Anyway, so what is the name of the hall, Ananda? Gularatna. I have forgotten that also. Am I old or do I have a which one should know both? So, suppose it is the parents' day. So, many parents are here in the Gururatna Hall. Then if I ask you, Puta, your parents are here? You say, yes. They are, some they are here. But I cannot say, then this is your parent. Cannot say. It is same thing. When you say there is a real number x such that x cube plus 3x minus 5 is equal to 0, all you know is there is one, but you don't know which one it is. Sometimes you may not know how to find. I know there is a method to find. Have you studied? I guess not, no? No. Cubic equations you don't study. I have studied. I have forgotten. It's much more difficult than quadratic equations. When I say in comparison, it's not a big mathematics thing, but cubic equation solutions are not easy. However, proving it has a solution is very easy for me because I know more analysis than you do actually. You haven't studied analysis yet, no? So what I am trying to say is, just because of I know that your father or mother is here, I cannot pick anyone and say, oh, this is his father. Similar thing is, just because I know that there is one real number like this, I cannot say, I choose e to the 3 plus 3, e minus 5 is equal to 0. I cannot say so. But since I know that x minus 1 cube is equal to x cube minus 3x squared plus 3x minus 1 for all real numbers, x, then I can pick any number. You may pick e, so you can say e minus 1 to the 3 is e to the 3 minus 3 squared plus 3 minus 1. Somebody may pick 5 minus 1 to the 3, like that. So it is very important. Actually, I told you the maths is difficult because of the quantifier there exists as well as this implication. These are the two things which make pure maths difficult. It's not difficult, but we are very lazy now. People are in general very lazy. Not only in this country, our people are much more lazier than the rest of the people in the world. So, we don't want to think. That's why we say it is difficult, but it is very beautiful. However, if you know that x cube plus 3x minus 5 is equal to 0 for some real number x, then you cannot pick, simply substitute in any real number you wish, example 5, and conclude that 5 to the 3 plus 3, 5 minus 8 is equal to 0. That's not true. You don't know whether it is true or false. However, you know that x cube plus 3x minus 8 is equal to 0 for some real number x. Very important, you have to get that to your heart. When you, which is very important, I mean it looks simple but very, very important. X cube plus 3x minus 5 equals 0 for some real number x. If you are told like this, what you know is, you don't know what the number is, but you are very sure there is such a number. There is such a number. Actually, even for the time being, I also don't know how to find it. I have studied, but I have forgotten. And you haven't studied also. You haven't studied also. But here when you say so, then you can plug any real number. It's very, this one and this one are very different. For instance, you know that there is x belongs to R such that x squared minus 2 is equal to 0. You know that. I don't know whether you know it. Because here actually, in this text, he teaches analysis first. Logic is at the appendix. So he's assuming here and there some analysis statements, but it doesn't matter. However, there exists x belongs to R. There exists x belongs to R such that x squared minus 2 is equal to 0. This one is true. Proof is very easy. when you do analysis, but we haven't done any analysis yet. What do I say? For instance, you know that there exists x belongs to R such that x squared minus 2 is equal to 0. Assume you know it. But you cannot write the number x such that x squared minus 2 is equal to 0. I can prove this is true very easily. You also will be able to prove this one after, say, after you begin third chapter or fourth chapter, I cannot remember. You learn how to prove this thing. But the amazing thing is, nobody in this world can write such a number. It is that's why I say this thing is highly complicated. Everyone knows this one is true. Actually, this is, you know this one. If you take the right angle triangle, this one is 1, this one is, both the sides are 1, and the other side, if you say x, then x squared is equal to 2. So there exists x belongs to R such that x squared minus 2 is equal to 0. This is sort of a proof. You cannot use pictures to prove theorems or anything. Never. Yeah, when you are doing a geometry problem, though you draw the problem, you cannot use, though you draw a picture, you cannot use the picture to prove anything. You cannot. We know this one is true, but nobody in the world knows what this number is. They cannot write it. I told you this the other day, even you are Buddhist, no? Before you reach Nibbana, I don't know, you will find, I don't think. Nobody can find this number. But that's the power of there exists. There is such a thing, but nobody knows. It is like somebody shot this John F. Kennedy, President of the United States. This guy has the highest. Now, how about this? North Korean man has the biggest guy. No, it's kind of funny. But anyway, John F. Kennedy, somebody shot him. He says somebody. That is true, no, that's how he died. No? But nobody knows the person. So, power of there exists. There exists a person who should John F. Kennedy. But we don't know. So it is like that. However, you can of course still conclude that x squared minus 2 equals 0 for some real number x. So sometimes for some examples you can pick x if you are lucky. But in geometry, almost always you don't know what the number is. All you know is there is such a number. For instance, good example. You know that I have a wife. But do you know? No, you don't. You don't know who my wife is. You know there exists a lady who is Dr. Ramasinghe's wife. You know that is true. But how do you see? You who the person is? No, you don't know. So it's so powerful. As I told you, this is one reason analysis or calculus is very difficult. Because it is an imaginative thing. That is the problem. But that's when you do difficult things, it's fun, or no? You get excited, no? So that's how those who like exciting things, they like to do geometry. It is fun, very exciting. Okay, some examples of proofs of and quantifiers. I'm writing, following the book, no? Some simple examples are of proofs involving the 4 rule and there exist quantifiers. Let's go through this proof carefully. Let me erase the board. Good morning. Where are you? Coming to lecture. Okay, welcome. You told me the other day you are
Answer. Today I had it.
Eh?
Today I had it.
You did go.
No, I had it yesterday.
You don't have.
Yeah.
Even I told my friends that I have a student in the class. Look at this one, for proposition here. For every epsilon greater than 0, there exists a delta greater than 0. This is delta. This is epsilon. Such that two delta less than epsilon. He has chosen this kind of very easy ones to give you the idea of the proof, not because of they are difficult, how to write. What this says is, no matter which positive epsilon you choose, no matter, it doesn't matter what you choose. There is a number, another number, positive number delta. What is the property? 2 delta less than epsilon. So at the very beginning, if you don't understand this thing, read it 10 times till you get the idea. Because analysis is always for epsilon, there is a delta greater than 0, for each x belongs to this thing, like that. So we need to understand, all it says is, no matter which epsilon you choose, there is a positive number delta. How? Such that 2 delta less than epsilon. Actually, this is something you can prove. I am sure you can prove it. Let's see whether you can tell me the proof. Maybe you read the book. It doesn't matter. So, Buddha, where? So, can I call you late Buddha? Because when you come, you don't come usually on Wednesdays. But today here you are, and still you are late. How come you are late today? What's the reason?
I forgot I woke up yesterday.
Okay. So we want to prove for every epsilon greater than 0. There is a number delta. In this, on the board, is there a positive epsilon? I mean, for instance, say, I say 4a. I'm always like, I'm lazy. Assume this one is true. For each country, in the world, there is a city, there is a city. In that country, called the capital of the country. I don't know this. If I were writing a book, I will check whether this is true or false. But assume, in general, this is true. For each country in the world, there is a city in that country called the capital of the country. My question is there a country on the board? Is there a country we are considering? No. Is there a capital? Is there a city we are considering? No. Nothing like that. All it says is, no matter which country you choose, there is a city in that country called the capital of the country. It is like that here. There is no epsilon. There is no delta. But there is a statement about based on epsilon and delta. So, Kuta, could you tell me how do let me do it. Easy example. Because I am following the book now because As a result, I am not bringing my examples. Some discrete example. Let's say capital A, let's take a set. Capital A is 2, 4, 6. 2, 4, 6, 8, 10. So that's 4, 6. Is this statement true? For each x belongs to A, there exists y belongs to A such that y is equal to x squared. Is this true? For each x belongs to A, there exists y belongs to A such that y is equal to x squared. Is it true? Putava? Yes? For each x belongs to, I take any x belongs to A. Right? Then I am saying there is another O equal y belongs to A such that y is equal to x squared. You are saying it is true. How about you, Buddha? False. Why do you say false? And you see, I ask him, why do you say false? That is the proof. Now he has to, whatever he tells me is the proof of the fact that this statement is false. So when you are writing the proof, you say proof, blah blah blah, you write in using proper statements. Why do you say that it is not true?
I mean, it's not true for all values in the A subset. It's only true for some.
For each x belongs to A. But I need the proof because we are doing logic now. If you want to disprove this line, what you should do? We are saying this is false. That means you are going to disprove it, not the proof, but disprove. So what is it? This statement is false. This statement is false. Proof. So how do you prove? In order to disprove this thing, what do you need? Yes.
To show that all x belongs to A, there will be y belongs to A such that y equals x squared.
Could you say it again?
Prove that, better prove that the sum of the x belongs to A.
Hmm. Gustavo?
There are
for some, I have to show that for some x belongs to A, there doesn't exist any y belongs to A such that y equals x square.
Okay, so if you are writing the proof, what will you write?
Choosing a number from the set and
So which number do you choose?
any number.
No,
Say 4.
when I ask which number, you can say any number.
4.
And 4. Clearly, 4 belongs to A. 4 belongs to A. Note, observe that. For each y belongs to A. For each y belongs to A. For each x, y is not equal to 4 square. No matter which y you choose, that y is not 16.
Now should be not equal.
Eh? Yeah. So next. No matter you choose your 4, then I am saying here the statement is for each x belongs to A, direct this y belongs to A such that y equals x squared. You are saying no. I will give you an A, no matter which y you choose, y is not equal to x squared. Actually, it is true for any number, not only for 4. Even if you choose 6, because you have to, mentally you must be thinking, you take 4. Is the square belongs to this set? No. You take 6. Is 6 squared here? No. You take 8. Is 64 here? You take 10. It's not here. So you need to be careful. Here again, when we come here, for every epsilon greater than 0. No matter which epsilon you choose, there exists a delta greater than 0 such that 2 delta less than epsilon. Here what we did was we disproved this statement. Here we have to prove this statement. If so, what should be the first line? This result is true. Actually, can you see that it is true? Do you see that it is true?
Yes.
Why?
Because if we assume that epsilon is 1,
Okay.
2 delta is greater than
Well, do you see that it is true? See, that is important. Before you write the proof for a very simple statement like this, I mean, you have to have the idea that you have to be able to see that it is true.
so
You said
if you assume epsilon is 1
1.
and delta is half of epsilon, so it's less than 1.
So if epsilon is 1, you choose epsilon to be 1, then
So it's 2 delta is less than epsilon.
okay.
So it's we put in the equation when delta is less than half.
Can we not pure mathematical yet, but he understands things. What is it? Why do you say it is true?
I can see that, but I can't
No, I'm not going to write what you are saying on the board. We are in a discussion. So why do you say it is true? You can say anything. Now, he began correct, but he didn't complete it correct.
So let's take epsilon to be any arbitrary number. Because
No. Don't say arbitrary number. I'm asking, why do you think it is true?
no matter the value we take for epsilon, if we take a positive value that is less than the half of that epsilon, it is still a positive number, but then that expression is true. Like we can show that.
So what do you say?
So it says for every epsilon is greater than 0.
Oh yes.
So let's say you give me any positive number. So I can choose a positive number which is less than the number you half of the number you chose. I can always do that. Therefore, that statement is true.
Can you see what he said? You take any epsilon. what he is telling me is somebody gives us epsilon. We pick a number less than epsilon by 2. Only thing is, it should be positive. Somebody gives epsilon, here is epsilon by 2, here is 0. Any number between 0 and epsilon by 2 will do it. That's what it says. No matter which epsilon you are given, you are saying there is a number delta less than epsilon by 2. Positive number. If you choose any number from here, that will do it. So, how do we write the proof? What is the first line of the proof?
Let epsilon be greater than 0 be arbitrary.
Let epsilon greater than 0 be arbitrary. The little thing I am not very happy is we should have done some finite examples. Now, for every epsilon greater than 0, when you say that there are infinitely many epsilons, so you have to write this kind of statements. Okay. So what this saying is epsilon is any positive number. Then what would you say, Uta?
The next no.
Yeah?
The next step.
Yes. I pick any epsilon. What is the next line? All I have done so far is I have chosen any epsilon, that's all. Because it is an infinite set, I cannot choose one by one.
Clearly choosing delta less than half of epsilon.
Now here, in this case, there exists a delta greater than 0 only. For each x belongs to A, there exists y belongs to B. Such that y is equal to x square. And I have two sets. Capital A has 4, 6, 8, 10. Capital B has 16, 36, 64, 100 and 101. I am saying for each x belongs to A, there in this y belongs to B such that y is equal to x square. Buddha, is that true?
False.
False. May Buddha, is that true? True. Why Buddha?
True.
True. Why do you say it is false?
Because there is no number in the set A that is the x square of 101.
X square one.
X square of 101.
I haven't written such a thing. What I have written here is, no matter which x I choose from A, there is a number y in B such that y is equal to b squared. Sorry, x squared. I haven't said that for each x belongs to B or for each y belongs to B, there in this x belongs to A such that y is equal to x squared. I have not written such a statement. Okay, let's prove this thing. Proof. How do you prove this thing?
Clearly 4 belongs to A.
Okay, very good. Clearly 4 belongs to A. Buddha, he said clearly 4 belongs to A, I wrote it.
4 squared equals 16.
Let me write one. Notice that 4 squared is equal to 16.
It exists in the B set.
4 squared is equal to 16 and 16 belongs to B. Right? Similarly, 6 belongs to A and 6 squared is equal to 36 and 36 belongs to B. Also, 8 belongs to A and 8 squared is equal to 64 and 64 belongs to B. Finally, 10 belongs to A and 10 squared is equal to 100 and 100 belongs to B. So I have wrote it. Here I took each element from A. 4, 6, 8, 10. Then I took the square, no? I got 16, 36, 64 and 100. They are in the set B. Since this set capital A has 4 elements, when I say for each x belongs to A, I can go one by one. Going 4 times, complete the proof. But in this case, how many positive epsilons are there in this world? Eh? Infinity. That's why I cannot do like this. Because I cannot write, for instance, let's take epsilon is equal to 1. Here I took 4, 6, 8, 10. Say you take 1. Then 1/4. 2 times 1/4. Less than 1. Then you can, epsilon is equal to 2. You can do like this, but that will not make a proof. Because how many times I have to choose epsilon? Infinitely many times. That cannot be done. Here, because it is a finite set, I go like this. I took the first one, second one, third one, fourth one, finish. Here, it is not the case. There are so many, infinitely many epsilons. That's why I have to write let epsilon greater than 0 be arbitrary. Here I don't write let x belongs to capital A be arbitrary. I don't write. Because I can do it precisely. I can do it precisely. That is the reason. Okay, now. You need to get this thing first. When we go to the book, continuity, differentiability, sequences, series, integration, everyone for each epsilon greater than 0, there is a all of them are like that. All of them are like that. Okay, let epsilon greater than 0 be arbitrary. Now what should I do with that? I had this thing, no? I had 0 here, epsilon here, epsilon by 2 here. All it says is, no matter which epsilon you choose, there is a delta greater than 0 such that delta less than epsilon by 2. That's all it says. So, what should be the next thing?
Let delta be greater than 0 and less than.
Again, you are making it difficult now. You have to, there exists delta.
Let delta greater than 0 be arbitrary.
I am going to bring a big stick mistake.
Let delta equal epsilon divided by 4.
Let delta equals epsilon divided by 4. I choose delta. Then I have to check 2 things. What are the 2 things? Is delta positive? Is 2 times delta less than epsilon? These are the 2 things I need to check. Since epsilon greater than 0, epsilon by 4 greater than 0, thus delta greater than 0. One part I proved. Also, 2 times delta. Oh, let's not write. Notice that. 2 times delta is 2 times epsilon by 4 that is epsilon by 2 is less than epsilon. So I have proved the 2 conditions. I have proved delta greater than 0 part here. Here I have shown 2 delta less than epsilon. You have to observe that. I took any epsilon, then there exists delta means I have to give the delta, if possible. I gave the delta. Because I know any delta here, epsilon by 4, epsilon by 3, epsilon by 8, any will do it. Then I chose delta since epsilon greater than 0, epsilon by greater than 4 greater than 0, thus delta greater than 0. Other condition is delta is positive, this one, 2 delta less than epsilon. I did that. Thus, this completes the proof if you want. You need to understand, no, copying down what I wrote on the board is not enough. You have to see that can you see I took any epsilon. Why? Because there are infinitely many epsilons in this world. In that case, I did not write like that. Because there are only 4 members. I can go one by one. Here I cannot do so. That's why I wrote, let epsilon greater than 0 be arbitrary. In Sinhala, epsilon ඕනම සංඛ්‍යාවක්. Epsilon is any positive number. It doesn't matter. Then I choose my delta to be epsilon by 4. Not I do choose. No? Then I have to prove that delta is positive and 2 delta less than epsilon. You need to understand that that's what we have to prove. Taking down this thing won't help you at all. You have to get the idea. If you are thinking alone, what I have to do is, no matter which epsilon I choose, positive epsilon, I have to be able to show that there is a delta, positive delta, twice of 2 times delta is less than epsilon. And yes, in my group also I have chosen epsilon to delta to be epsilon by 4, I guess. Yes, yeah. So you could have chosen delta to be epsilon by 8. There are so many. You need to get that thing to your head. I guess you are not getting. I'm a little concerned. Though it is very easy, we are going to deal with this kind of statements. When we begin the first chapter is of course discussion. Second chapter, or sooner or later, we are going to continuous functions, differentiable functions, sequences, degrees, all of them for each something, there is something for each something, like that. All of them are like that. You need to think. Okay, here I am saying since we were proving something for every epsilon greater than 0, epsilon had to be arbitrary. Because in that case there are only 4 numbers in the set capital A. Then I can consider one by one. Here I cannot consider. How many positive epsilons are there in this world? Infinitely many. On the other hand, delta could be chosen as you wish in this one. You need to show that there is a delta which does what you wanted. Did you observe that delta can depend on epsilon? Here delta depends on epsilon. We discussed about this thing on nested quantifiers. Inside one can depend on the outside one. Though this is very simple, idea is very important. Here I said, did you observe that delta can depend on epsilon? This is because delta quantifier is nested inside the epsilon quantifier. Epsilon is outside, delta is inside, so delta can depend on epsilon, but epsilon cannot depend on delta. You have to get that spirit because we cannot do logic forever. By Friday, logic will be over. We are going to the next lesson. So in these lessons, always we are writing this. They are exist overall, etc. Anyway, when one has to prove a direct statement, example, prove that direct is than epsilon greater than 0, such that x is true, one proceeds by selecting epsilon carefully. When you are proving for this one universal statement or for every epsilon greater than 0. However, certain statements direct is than epsilon greater than 0. Then we are in trouble. We cannot do like this. Prove that direct is than epsilon greater than 0 such that capital X is true, one proceeds by selecting epsilon carefully. If you are proving direct is epsilon greater than 0, then at the very beginning you have to know what your epsilon is. So that's why I say here, prove that direct is an epsilon greater than 0, such that capital X is true. One proceeds by selecting epsilon carefully and then showing that capital X is true. If you had epsilon first, you have to choose it very carefully and eventually you have to prove that capital X is true. However, this sometimes requires a lot of foresight. Most of the analysis problems, theorems we prove, we do it. We cannot choose epsilon or whatever the thing, direct is epsilon, direct is delta. At the very beginning we cannot do it. Once in a blue moon we can do it. We proceed and try to discover what are the other things this should satisfy. When we come to proofs, we will see it requires a lot of foresight, that's what we say, and it is legitimate to defer the selection of epsilon until later in the argument. Though it is, if you had direct distance epsilon greater than 0, though it is the outside quantifier, you cannot use it right away. Because it has to satisfy some other conditions. So we postpone to the last minute. Or in other words, maybe we can do some rough work outside. From rough work you learn what epsilon should be. Then come back and start writing. When it becomes, that's why I say, when it becomes clearer what properties epsilon needs to satisfy. The only thing to watch out for is to make sure that epsilon does not depend on any of the bound variables nested inside capital X. If you had direct distance epsilon greater than 0 such that capital X is true, two things at the very beginning, you cannot find epsilon. When you say you, I cannot do it either. I mean, even Terence Tahoe cannot do it either. You proceed. What should be true, what is the thing, this and that you continue and you eventually find out. However, you eventually find out what epsilon needs to be. However, epsilon cannot depend on capital X. Direct is epsilon greater than 0 means epsilon is either it is an actual real number or like epsilon by 4, epsilon by 2, that kind of thing. You need to be careful. Here there is a good problem. So even though I say good problem, it has a mean value theorem. Still I wrote it because we are following this book. proposition. There is an epsilon greater than 0. Such that. Now you must be familiar with this thing. You say the Rn is such that. Always it comes. If you write for each epsilon greater than 0, come. Such that sin x greater than x by 2 for all zero less than x less than epsilon. So this is a difficult one. We have to show that there is an epsilon greater than 0. How? Such that sin x must be, there is some epsilon here. Epsilon is somewhere. We have to find it. How? Such that if you take any x from here, you take x from here, then it should be the case that sin x greater than x by 2. This is difficult one. How can you use epsilon? Epsilon cannot depend on x. Epsilon is some number, maybe phi, square root of 2, this and that. So this is, that one is far more difficult than this one. Far more difficult. It's not the difficulty. We should understand that it is difficult. We should try to understand from where on earth I can get an epsilon. I have to get the epsilon. How? No matter which x you choose from here, sin x must be greater than x by 2. You need to understand that it is not obvious at all. That's the main important thing. You don't have to be able to solve this problem. No, I don't expect. But you have to understand it is from where on earth I find this epsilon. My gosh. Sin x greater than x by 2 if you took any x between 0 and epsilon. You do understand what I am saying? Here I am saying, I suppose you cannot guess how to prove this proposition. We use mean value theorem to prove this, which you will study later. Mean value theorem is a very important theorem we are going to study later. But to explain this one, let's go through it. I mean, we are not going to be master in mean value theorem. So, this time. So let's take the break now and 6 or 7 minutes to 5. I mean 11. So after coming here, okay, let's start. Okay, thank you, Buddha. So we have a proposition to prove that there is an epsilon greater than 0 such that sin x greater than x by 2 for all 0 less than x less than epsilon. We have no idea whatsoever how to find this epsilon. No idea whatsoever, not at all. However, he is using mean value theorem. I mean, of course, you have in what it says is that if I have drawn, this is the point A, this is the point B, then this is AFA, BFB, then if you join these two lines, FB minus FA over B minus A is the slope of this secant line, slope of this line. So what mean value theorem says is that there is a point in between A and B such that at that point tangent slope of the tangent line is equal to slope of this line. In other words, slope at this point, in other words, this tangent line and these are parallel. In other words, what mean value theorem says is, if all these conditions are true, there is a point at which tangent to the graph at that point is parallel to this line. That's what it says. Of course, there are other ways of saying. So he is using that. When I say this thing, I'm very unfair because you don't know the meaning of continuous, you don't know the meaning of differentiable. Many people, and you told me this, your teacher also does not know. That's the way. Anyway, so we are going to use mean value theorem to tell you the truth. If you give me this problem, I myself cannot solve. Right away I have to think. It is not like 8 times 7 is 56, can tell right away, no. It's not like this, even if I am given. Because especially there exists epsilon greater than 0, because we cannot start. How can we start? Let epsilon equals, can we write? No, we don't have any idea. So tangent at the point C, note I have put C here, it's not X. And then C. I have to put C. Okay, so the tangent at the point C is parallel to the secant line joining AFA and BFD. This kind of line is called secant line. That's a mathematics word. Secant line. S-E-C-A-N-T. If you take any graph, when you join these two, this is a secant line joining 2 points on the graph. Secant line. So what this says is, what mean value theorem says is, there is a point at which tangent line is parallel to that secant line. That's what it says. So let's go through this proof because it is important to understand, though it is difficult, the procedure. It is difficult for you. You may not understand everything, but it doesn't matter. Why do I say it doesn't matter? When I was in the States, I have studied Banach spaces, you don't know that word even, Banach space conference in an American university. I went there, from my university there were many people, it is international. India, Germany, Switzerland, from every country there were people. Dr. Prabhat, I guess he had studied harmonic analysis, HARMONIC. So there was a lecture, some big shots in the world delivered a lecture on harmonic functions in the somewhere. Let's not go to the details, you don't understand. I understood first 5 or 10 minutes of his lecture. I didn't understand anything thereafter. So I was just thinking about Sri Lanka and how I have to spend that time. So after the lecture is over, my analysis teacher at that time, he was also there. He is a Jewish person, so he is an expert in something called operator theory in the world. He asked me, they used to call me Rama, how do you find the lecture? I told him, first 5 or 10 minutes I managed. Thereafter I didn't understand anything, not a single ball. Then he told me, don't worry, you are not alone. Can you see? That's the way mathematics is. If you don't understand, don't feel bad. Many people don't understand. So many don't understand. When I was doing a PhD, there was another guy doing PhD. He's from Romania. So one day I asked him some problem from rooting. You may have heard rooting. That problem is very difficult. I asked him how to do it. He didn't say he cannot do it. Rama, you don't get anything by solving this thing. Which is true, no? I mean, if you do a research, then you are proving something, you are solving a problem that nobody else has done. He cannot solve a single thing. So don't worry if you don't understand. But very important that you understand that you don't understand. That is important. It's not important for you to understand everything, but very important that you don't understand. You understand that you don't understand. Alright, okay. So that is the way. So then actually that day I was very happy. I was feeling bad. I was thinking maybe I was the only person who couldn't understand this. Finally my teacher couldn't understand it either. Quite often it is the case. Quite often it is the case. So do not worry. Let's read this. We pick epsilon greater than 0 to be chosen later. Can you see? We do everything, though it begins from there, it is an epsilon greater than 0. What he says is, we pick epsilon greater than 0 to be chosen later. And finally, only we are choosing epsilon, because we go through what are the properties it should satisfy. If I were to prove this thing in my own, I say, in Colombo University or in Ohio State, I put a square like this. I do rough work here. They can see this. Blah, blah, blah. When it comes to here, you see what epsilon needs to be. From here, then I come and write, let epsilon be there. Do you see what I'm saying?
Yeah.
So that is my way of proving in front of students. Always I have some kind of a rectangle. I do the work there. From here I get the epsilon, so I have done so much of work. Then I write like a hero, this is my epsilon. So, if I write that epsilon without my work, students will not understand. Sir, from where on earth did you get it? Can you see? Okay. We pick epsilon greater than 0 to be chosen later and let 0 less than x less than epsilon. We don't know what epsilon is. So we'll take some epsilon. We are going to find out what are the qualities or properties it has to have. And we choose x in between. Since the derivative of sine x is cos x, we from the mean value theorem we have sine x, if you take sine x or sine minus 0 over x minus 0. So if you take the function to be fx equals sine x, this is fx minus f0 divided by x minus 0. Like this, no? fb minus fa divided by b minus a. Derivative of f at some point c. So this is going to be equal to cos, derivative of sine is cos, no? Cos y for some y. For some 0 less than y less than x. So it follows from this theorem. Sin x is continuous every place. Sin x is differentiable every place. So this continuous part is very clear. Differentiable part is also very clear. So that's why there is fx minus f0 divided by x minus 0 is f dash, derivative of sine is cos, for some y in between. Can you see? Thus we have here, from here sin 0 is 0. So maybe I should write here sin x over x also. Sin x over x is equal to cos y for some y in between. Thus we have sin x over x something I have written incorrect. Written something incorrect. Sin x over x greater than something wrong. Can you see I have written something wrong? That line is incorrect, no? Sin x over x is cos y. So it is incorrect. Sin x is equal to x cos y, not greater than. On page 26 first line. I am writing properly. You see what I am saying? Sin x over x is equal to sin x. I have written greater than sign, that's not true. Sin x is equal to x plus y. Hence, I say, can you see, we are in the process of finding epsilon. That's why I told you, it is, you cannot write right away. That's why I told you, when you ask me to do it, in my case, I do the home, I say it is rough work. Here I do rough work. Maybe doing lots of things, I find out some properties of epsilon, then I write, let epsilon be like this. So if I erase this thing, students will get scared. From where on earth you got this thing? In order to ensure that we want sin x greater than x by 2, no? So then if cos y greater than 1/2 by any chance, then we are done, no? We have sin x equals x cos y for some y in between 0 and x. If by any chance cos y greater than 1/2, then we are done. That's why I say, hence in order to ensure that sin x greater than x by 2, it could suffice to ensure that cos y greater than 1/2. If cos y greater than 1/2, then we are done. So then we have to choose, make sure how, by doing what, we can make cos y greater than 1/2. So let's have the graph of cos here. This is 1, this is 5 by 2. 1/2 is in between. So cos 5 by 6, no? 1/2? 5 over 3? Oh, not 6. 5 over 3. Cos y greater than 1/2 if y is in between 0 and 5 by 3. Right? So that's why I say cos y greater than, it is enough. To do this, it would suffice to ensure that you take y from this region. Y must be coming from here. 0 to 5 by 3 interval. So far we have no idea about epsilon, but we know sin x is equal to x cos y for some y in between 0 and x. If cos y greater than 1/2, then we are done. However, cos y is equal to 1/2 at 5 by 3, and between 0 and 5 by 3, cos y greater than 1/2, right? Cos y greater than 1/2. To do this, it would suffice to ensure that y is in between 0 and 5 by 3. Cosine function takes the value of 1 at 0, takes the value. I have drawn the graph now, half at 5 by 3, and is decreasing in between. Since 0 less than y less than x, we have 0 less than y less than x, and 0 less than x less than epsilon. We have 0 less than y less than epsilon. Y must be less than epsilon. Thus, if we pick epsilon to be 5 by 3, now if we pick epsilon to be 5 by 3, then what will happen is 0 less than or equal to y strictly less than 5 by 3, and hence cos y we get greater than 1/2. Thus, sin x greater than x times 1/2. That's what will happen. So that is the trick here. From mean value theorem, you got sin x is equal to x cos y. We need this thing to be greater than 1/2. That means we need cos y to be greater than 1/2. No? That means we need y to be between 0 and 5 by 3. So that's why we choose epsilon to be 5 by 3. Then y is in between 0 and 5 by 3. Therefore, cos y greater than 1/2, then we are done. So our epsilon is then 5 by 3. Our epsilon is 5 by 3. I have written it here. So after doing this thing, I have written the proof, you can see. But this is the important part. You know from mean value theorem, sin x is equal to x cos y for some y in between 0 and x. That's what we know. So if x cos y greater than x over 2, we are done. That means cos y greater than 1/2. That means y is in between 0 and 5 by 3. So as a result, we pick epsilon to be 5 by 3. Then cos y certainly greater than 1/2. Then we are done. Very simple. But at the very beginning, did we have any idea? No. Not at all. So we should come back to this thing after chapter 8 again to make sure that you get it. Here, this is not fair, but what to do? It's not a fair way. What is here you need to get the message is that when you are writing, proving a statement for each epsilon greater than 0, you can begin let epsilon greater than 0 be arbitrary. That means yes.
Sir, he understands the last part.
Eh?
The last part I don't understand.
No, nothing to understand. Let me explain again. You notice sin x over x is equal to cos y. So I get sin x is equal to x cos y. I want sin x to be greater than x by 2. So that means I need x cos y to be greater than x by 2. X is a positive number. Then you can cancel x. Cos y greater than 1/2. When will I get cos y greater than 1/2? From this picture? when y is in between 0 and 5 by 3. So as a result, then I took epsilon to be 5 by 3 because y is in between 0 and x is in between 0 and epsilon. So I chose epsilon to be 5 by 3. Now, if you don't understand this stuff, look at this picture. You take epsilon to be 5 by 3. Then your y is in between 0 and 5 by 3. Then cos y is greater than 1 half. Therefore, x cos y is greater than x times 1 half. That is it. What I am saying is, at the very beginning, how on earth you know that you have to apply the mean value theorem to solve this problem? That's why here somewhere you notice that you have to have a big foresight. That is the difficulty in analysis. It's not in A-level problems, it is mechanical. No? If you are doing f equals ma, you can write 3 equations. No? This way, like that. You solve it and that's it. Here, when you are given this problem, you have no idea whatsoever this is an application of mean value theorem. You don't know. That's why you have, I say, intuition and insight. Here, insight is the mean value theorem. Insight comes from mean value theorem. That is the thing. You understand, no? How about you, Buddha? It is, forget about all of them. You, from mean value theorem, sin x over x is cos y. Therefore, sin x is equal to x cos y. You need this to be greater than x by 2. Since x is positive, you can cancel. Then cos y must be greater than 1. That is, y must be in between 0 and 5 by 3. From the graph, cos is decreasing from 1 to 1 half between 0 to 5 by 3. So if you put epsilon to be 5 by 3, then everything is over. That is the thing. Anyway, so as far as you are concerned, this is not a problem you can solve because you don't know about continuous functions, you don't know about differentiable functions, you don't know about mean value theorem. Mean value theorem is one of the very important theorems in calculus with whole bunch of big applications. Are you very sure or shall I explain it again? I can do it. Okay. Then we want to prove that there is an epsilon greater than 0 like this. Then let me erase this part to make it crystal clear. So let's do our way now. Thus we have sin x equals x cos y. Let me get this. Now this is not the proof, but how to get the proof? We need x cos y greater than x by 2. That's what we need. Therefore, in that case, sin x greater than x by 2. Buddha. Since x is positive, we need x greater than 1 half. We need x greater than, because I can divide by a positive factor. Inequality remain the same without changing. x, not x, cos y. Since y is positive, cos y, y is positive, cos y, no, we go write this thing. Okay. We know that cos pi by 3 is equal to 1/2. That also we know. And we know about the graph of cos. So, we need cos y greater than cos 5 by 3. That's what we need. Cos y greater than cos 5 by 3. According to cos graph, according to graph, y then must be less than 0 and 5 by 3. Y is between 0 and 5 by 3. If you are very sure y is going to be between 0 and 5 by 2, we are done. That's why I say put epsilon to be 5 by 3. Because of all that. At the very beginning there is an epsilon I did not write. I have written this one. If I want, I can start the proof without all this, put epsilon to be 5 by 3, then somebody who is going to read the proof does not know from where on earth I got epsilon equals 5 by 3. Now, hereafter everything is clear, no? Epsilon is 5 by 3. Then now you take, now let x between 0 and epsilon is equal to 5 by 3. Then you can write sin x within x, right? Sum is equal to sin x minus 0 over x minus 0 is equal to cos y for some y. Right? Since y is between cos by 3, therefore sin x over x equal to here then greater than 1/2. Therefore sin x greater than x by 2. Crystal clear or still there are doubts? To you? So can you see it now? Sometimes people write the proofs, they begin from here. Then the reader does not know from where on earth he got this thing. That's why in my case I said I have the rough work when I am proving. You will see in the future I am proving many theorems, so we have to go through. So in his case, he, without saying rough work, he did the necessary job to find epsilon. Here actually, what we have done is we have find epsilon. Different way of writing in find epsilon greater than 0 as that. That's what actually we have done. Anyway, so for the time being, let's quit it there. Think about it. We will come back to this kind of things. more and more. Now, among the things I have done in my notes, is there anything that is not clear to you in the notes that I did? Because we have discovered, now completed with the book has equal sign, it's no big deal. If x is equal to y, then y is equal to x. I mean, these are obvious things, so I don't want to spend time. Anything which is not clear, we have this. If there is anything not clear or is bothering you or something, and do you know how to write the negation of the things you have learned? Little summary. I told you before, we use this thing for each or for all, etc. This thing for there exists. Again, now this symbol for if then, this one for if and only if. This thing, I just, how does it write? Note. It has a symbol here. I forgot what it is. This one for not. This one for O, this one for N. These are symbols. For each there this implies if and only if, not, and. These symbols are used. You don't practice, try to, use the symbols when you are writing. Because in A level, if you look at I should have wrote some A level solutions. The way they are using the implication symbol is absolutely wrong. If and only symbol also, absolutely, that simple implication symbol, absolutely false. What happens is that when you are a child, if you have been saying from your childhood to a coconut tree, it is a rose tree. Today, when you see a coconut tree, you will say, "Oh, it's a rose tree. Where are the flowers?" So it is very bad to have the misuse of implication symbol. That is why students find it very difficult to learn when they go to the campus. It's a very bad thing. I have written to Commissioner of Examination several times, but nothing happens. Now you know the meaning of not. O and implies if and only for each. Now you should be able to write the negation of any of the statements. If you say P or Q, what is the negation of P or Q?
Not P.
Very good. What is the negation of P and Q?
Not P or not Q.
What is the negation of P implies Q? No, I mean, you are saying the situation. No, you said if P is true, then Q is false. No, that's not the negation. If P is true, then Q is true. Anyway, when you are given if P then Q, he says X, no? If X then Y. I am the person. All the authors in the world, including I myself, except this professor, they use PQ for the statements, but in this book you have if X then Y. So, what is the converse of this statement? Converse. Converse.
If Y then X.
If Y then X. Converse is. What is the inverse of if X then Y?
If not X, then not Y.
If not X then not Y. What is the contrapositive of if X then Y?
If not Y, then not X.
So when you are given a if then statement, which we call an implication, converse is again an implication, inverse is again an implication, contrapositive is again an implication. Very important. And we know this one and this one are equivalent. Can we prove it? Let's prove it. So this is a difficult one, by the way. Not the proof, but you don't know me in a theorem, etc. I did it because to give you the idea that when you are starting to do something there exists, maybe you do many other things to find epsilon. There exists, whatever. If it is there exists X, then you will have to do some work to find that X. What did I say? I said that proposition. So far, by the way, you knew negation of this one, negation of this one. So far, we did not write that if X then Y. No, we didn't write. Proposition, what did I say? If Y, if X then Y is logically equivalent. If not Y, then not X. Right? Logically equivalent. Proof. How do we prove? If you want to prove logically equivalent, there are several ways of doing it. You assume, let's put some quotes, otherwise it's not clear. You assume this one is true, then you prove this one is true. Conversely, you assume this one is true, then you prove this one is true. Or else, you assume this one is false, prove this one is false. And assume this one is false, prove this one is false. So, how do you want me to start? How do you want me to start?
Assume the first statement is true and show that the second
Oh.
statement must be true.
Suppose if X then Y is true. Now what do I have to do? Puta, what do I have to do? Do you know the meaning of logically equivalent? Means what? Logically equivalent means
Both the statements
both the statements
have the same meaning.
have the same meaning. Very good. Both the statements mean the same thing. That's what logically equivalent means. So, in that case, I have written, according to this Buddha, I wrote, he said, start, assume first one is true. I said, suppose if X then Y is true. Now, what do I have to do? Very good. Need to show that. You don't have to write need to show that. Because I am teaching, I am writing need to show that. You also can write if you want. It's not necessary. Need to show that. If not Y, then not X is true. Okay. In order to do that, now what should I do? Now all I want is to show that if not Y, then not X is true. So now what should I do? I want to prove the statement, if not Y, then not X. So, from Mebuta, from where can I start?
It is clear that.
Eh?
It is clear that.
No. Clear that from where should I start? What do I do? I am not asking you to do it.
We need to show that if Y is not true, X is also not going to be true.
We can show that if not Y, then not X is the inverse of if X then Y.
No, now I have to prove a if-then statement of an implication. How do we prove an implication? Say suppose I want to prove if P then Q. How should I start?
Suppose P is false.
Suppose P is false.
True.
Maybe you are mad at I alone.
Having proof by contradiction, I thought to like prove it by using the contradiction.
No, suppose we want to prove if P then Q. How do you prove it? That's what I am asking.
Yeah, I tried to prove it by contradiction. That's why I told suppose P is false and then
You are saying if I want to prove if P then Q, you say
to use proof by contradiction.
we cannot use the proof by contradiction so far. We don't know to write negation of if I then X. May Buddha told me, but it's incorrect. Proof by, you understand Buddha? If you want to use proof by, that's very good anyway. You brought the word. Here I did not mention proof by contradiction. Proof by contradiction is a very good method. However, if you want to use proof by contradiction, you have to be able to write the negation of what to be proved. You understand? If you want to use the proof by contradiction to prove something, then you should be able to write the negation of what to be proved. Now in this case, so far you don't know how to write the negation of if X, then Y. Therefore, we cannot use that method, though you are correct. So then we have to follow what this Buddha said. That method is called direct proof. In the direct proof of if X then Y, what should I write first? I want to write the direct proof of if X then Y. So how do I start the proof? Eh? No, you are completing statements. In the direct proof, what should I do?
Assume the first statement is true.
Eh?
Assume the first statement is true.
So assume what statement is true.
Not to I.
Okay. Assume not Y is true. See, we want to do this thing. Let me add some. To this end, assume not Y is true. Assume not Y is true. If not Y is true, then Y must be false. Thus, Y is false. Thus, Y is false. Now, I am in the process of showing that, need to show that if not Y, then not X. Now, in the direct proof, according to this Buddha, I haven't learned 3 names, because those who are attending here is not an invariant. You don't come some days, you come on some other days. Anyway, doesn't matter. Other Buddha, me Buddha, this Buddha, doesn't matter. I have assumed this line, if X then Y is true. I want to prove if not Y then not X is true. So I said suppose if X then Y is true, I want to show that I hold if not Y then not X is true. To write the direct proof, to this set assume not Y is true, thus Y is false. I know Y is false, and if X then Y is true, then I know something about X. What do I know? False. Because if x then y is true and y is false, we have what? If x then y is true and I know y is false, we have what? We have you just say nothing is going to lose. However, don't say for the sake of saying, think first and say, because we are going to learn.
X is false.
Very good, we have x is false. Very good. If x is false, then not x is thus. Not x is true. So now what we have done? We assume not y is true. We have shown that not x is true. Thus by direct proof, if not y, then not x is true. Understood?
Yeah.
Well, so I have done one side now. I assume if x then y is true. I have shown that if not y, then not x is true. Clear? Ne? Now I have to do what? I am on the way to prove the proposition if x then y is logically equivalent to if not y then not x. So I have assumed this one and have proved this one. Now what should I do?
Suppose if not y, then not x is true.
Very good. Since I wrote here, suppose, now I will say, now suppose. If not y, then not x is true. If not y, then not x is true. Am I logical or am I acting like a big shot? So you have to get the feeling. It's important. Because we are on the way to do analysis, sequences, series, fun things. You have to know this very well. If not y, then not x is true. Need to show that. You don't have to write it. I told you. When I am doing a difficult program for me, when I am writing the solution, I always write need to show that because I have something need to show that. If x then y is true. Two, if x then y, quote here. I have assumed, no, I have supposed, now suppose if not y then not x is true, need to show that if x then y is true. In order to prove that if x then y is true by the direct proof, what should I write first now? You know this.
Assume x is
I can erase this, no? You don't.
Yeah.
Uta, you said something.
Assume x is true.
Assume, very good. Assume x is true. So, to make sure, to this end, assume x is true. We want to prove this thing by direct proof, so we will assume x is true. Now I want to show y is true. However, I know that if not y, then not x is true. If x is true, thus
Not x is false.
not x is false. Not x is false. Now I know not x is false and the whole statement is true. Therefore, what do I know?
That not y is false.
Huh?
That not y is false.
Thus, not y is false. When I say this thus means this because it is true. Thus y is false, not y is false. Hence, y is true. Now what is the case? I have assumed x is true. I have shown that y is true by direct proof. If x, then y is true. This completes the proof. Okay, so but unknown, you have to check whether it is really logical for you. Because we are on the way to do analysis.
So if is the negation of if x then y is if x then not y.
Almost there, but not there. All right. So now, what? Before anything else, so let's think about the negation of if x then y. If x then y, what we know is it is always true. Only time it is false is x is true and y is false.
So is the negation if not y then x?
If x then not y.
Negation of if then xy is not the if then statement.
Okay.
Anyway, so let us say proposition.
X and not y.
Negation of the negation of if x then y is x and not y. See whether we can prove it. Negation again is again in this one, if x is true by any chance, then y must be true. Here right away x and not y. Right away. So let's see whether we can prove it. Because we need to be able to write the negation of everything we learned. Otherwise it is incomplete. No? I mean, it is not done in the book, but we are going to learn analysis, so it's important. So what we will do is, we assume, suppose if x then not y is false. If x then y is false. then if this theorem is true, then x and not y must be true. Maybe the hurry, but did you get what I said? So let's write that. Assume if x then y is false, what do we know, Bhutale? If x then y is false, x is false. If x is false, if x then y is true, equationally true, I said. If x then y is false, we know something for sure. What is it? Buddha?
Y is false. Even if x is true, y is false.
What I am saying is, I know this statement is false. Then there is something we can say right away. What is it?
X is true. If x is true, then y is true. Y is false.
No, no. You have to speak mathematically. You can tell the answer, however. I am saying if x, then y is false. Is false. I have incorrect. Thus, x is true and y is false. X is true and y is false. If y is false,
Not y is true.
not y is true. Thus, x is true and not y is true. X is true, not y is true. Hence, x and not y is true. Right? So, half of the roof is done. Half of the roof. If x then y is false, then x and not y is true. Now we have to show that if x then y is true, if x then y is true, then x and not y is false. I have to show. So I can say, now assume if x then y is true, if x then y is true, then one thing I know, it cannot be that x is true and y is false.
Yeah. So either it should be false or x is
Then,
true and y is true.
it is not the case that x is true and y is false. Yes. it is not the case that X is true and Y is false. Then what?
X is false or Y is true.
X is false or Y is. I have written, it is not the case that X is true and Y is false. Therefore, X is false or Y is true.
Then it is not the case that X and not Y.
What did you say? It is not the case that X is true and Y is false. Thus, hence, X is false. No?
Yeah.
O, Y is true. X is false or Y is true. Thereafter what?
Then X and not Y is false.
You are saying therefore X and not Y is false. Are you there? Hence, X is false or Y is true. Hence, X, you said, and not Y. Oh. We are assuming this one is true. We have to show that that guy is false. So we have X is false or Y is true. Therefore X and not Y.
So the upper line, the X is true and Y is false.
Where's answer?
It's not the case that thing.
Yes, the
If X then Y, this line is correct.
yes.
Next line, X is true. It is not the case that X is true and Y is false. It cannot happen.
It is the same. It has the same meaning as X and not Y is true. That part. Like if Y is
X is-
false, then not Y
They
is
all
true.
have the same meaning.
After this line, you are asking me.
If Y is false, then not Y is true. So I mean, I'm saying like X is true and not Y is true.
Yeah.
X is true and not Y is true.
Yeah.
Okay.
Not Y is true. Yeah.
X is true and not Y is true.
Yeah.
So it is not the case that X is true and not Y is true.
This is small.
You are rewriting different words, no? Not my idea. Okay, let's do it. Again, then you are saying thus. You are saying the same thing, no? This is not the case that X is true and not Y is true. Okay, then what?
Therefore, X and not Y is false. statement is false.
Exist. Hence, X and not Y.
It's false.
Correct? Is it? It is not the case that X is true and Y is false, that is very true. Thus, it is not the case that X is true and Y is false means not Y is true. So then you are saying, hence, X is true and not Y is true. So X and not Y is false. Correct? Is it correct?
So the line before the last one says the negation of the statement is false, right? Thus it is not the case. The negation of that statement is false. So it is true. Therefore the statement must be false. That's what we've written.
We are saying if X then Y is true, assumed, right?
Yes.
So then it is not the case that X is true and Y is false. Something cannot happen. Thus it is not the case that X is true and not Y is true. So I'm a little bit.
So I don't understand that.
Eh?
I don't understand the line before the last.
You don't understand the line before last?
Thus it is not the case that X is true and not Y is true.
Second line is thus it is not the case that X is true and Y is false.
Yeah.
Same thing of the third line. It is not the case that X is true, Y is false means not Y is true again. Same thing. But is it the complete proof?
I think there should be another line to make it bit more readable. So you should write before the last line, I think, thus it is not the case that X and not Y is true. Then you finally convert it back. I
It
think
is
that's
not
better.
the case that
X and not Y is true.
you are saying add one more line.
Yeah.
However, you are saying what is on the board is correct. Is it to me, Buddha? You?
I think it is
X is true and not Y is true. Thus, it is not the case that X is true and not Y is true. Then the Buddha again, thus it is not the case that X and not Y is true. We can put that also. Thus, it is not that you can write it now. If the X and not Y is true. Hence, X and not Y is false. Harini? Yes? So the most important thing is negation of if you get an if-then statement, converse is a if-then statement. Contraposition is a if-then statement. Inverse is an if-then statement. However, negation is not. So very important, negation of if x then y is x and not y. Another important thing, by the way, before I run away, the useful one. This one clear to everybody? If x then y is logically pure, not x or y.
So it is like taking the negation of x and not y.
So that is a short proof, ne? By taking the negation from that proposition. So you can use that proposition to prove this thing, and you can prove otherwise also, without. So let's try to prove it. You see what is pointing out? If you take the negation over there, we have the proof. But let's try to prove without it. Because here we are trying to prove our knowledge. No, it's not that we prove, it's not an exam that we prove it, oh, I'm done. It's not the case, we are trying to understand it. If you can say, suppose you assume one side and prove the other side. Suppose you assume, suppose if x then y is true. Anyway, it is a very good observation. By taking the negation over there, you get it. Buddha, are you with us? You understand, no? See whether you can prove it alone. You need to say whether you feel it that important thing is that not that you write the proof, oh I am done, I proved it. It's not the thing. You have to feel it that it is true. Buddha, you understand, I wrote the proof on the board. I said, suppose this one is true. Then I am saying clearly X is true or X is false. One of them. Case 1 I take, suppose X is true. If X is true, and if this statement is true, then Y must be true. If Y is true, so not X or Y is true. One of them is true. Now I took, suppose X is false. If X is false, then not X is true. If not X is true, so not X or Y is true. There are two cases, that's very important. X is true or false, nothing else. Hence in either case, not X or Y is true. So I wrote, if this one is true, then this one is true. Now if you want, you can prove, if this one is false, this one is false. That's another way of proving. True, true, false, false. I guess that one you can do easily, no? If you assume this one is false, then X is true and Y is false. If X is true, not X is false. And if Y is false, then not Y is false anyway. So this is false, this is false. Both are false, this statement is false. You got it? Shall I write? So, I guess, are you now, you guys have some improvement in logic, no? Now I will, next day I will try to bring some problem set for you to do homework, no? They call it homework, I don't know. Now, what is the important thing is that not that you can prove it, you feel it. That's the important thing. You need to know how you should be able to write the negation of any statement you write. That's the important thing in maths. In other subjects, it's not important. Now, for instance, in O level, you learn two triangles are congruent if and only if something. And you get the questions to prove two triangles are congruent in O level. You never got a question to prove two triangles are not congruent. And you don't know how to disprove. Now, because you are in this class, maybe you can do it. But students don't know. They think triangles are congruent only. Because we get problems only in that direction. You see what I'm saying? We have to know two triangles are not congruent if and only if what. Like that, we have to be able to write the negation of everything we write. Then only we know that. If you know this, for instance, what is this? Brewing happiness. Across the island of across the island. If you know, I mean, some food is tasty, in order to know some food is tasty, you have to know some food which are not tasty. Very important. Otherwise you don't know. Otherwise you may be like a parrot saying. So then next day I will look at it, the logic thing, whether there is some other thing very important. We did not discuss about the negation of if and only if, no? If and only if. Maybe we should spend a little time for that, and then we go to first lesson. Then we are on the way to the lesson. Lesson, I will not write any notes, I will discuss. Because it talks, it says why should actually, it explains why should we study analysis. There are so many mistakes we do, it is giving many examples. So we have to discuss why they are wrong and so on. In the meantime, I will write some set of problems